I'm Anil Kumar. Welcome to my video on linear algebra. We'll discuss when we have variable on both the sides. We are considering single variable x being on both sides of the equation. So I've taken a few examples here, quite a few I should say. The first row here is with single variable on only one side, just to tell you what I mean by both sides. Then the next 4 rows of 3 each, that is 12 questions. We have x term on both sides of the equation. Now this is especially on a request from one of my subscribers who wants to understand how to solve such questions. So I thought, let me take a few examples. And I hope it is going to help many students, right? You can pause the video, take it as a worksheet, solve, and then look into my solutions. So let's go one by one. So we'll first take up cases when x is only one side of the equation. So we have 3 different equations here. The first one is 2 plus x equals to 5. Then we have 3x equals to 12. And then we have x minus 2x equals to 0. There is slight difference in these equations, but they are very simple to solve. We have the variable only on one side. When I say 2 plus x equals to 5, solve means to find the value of x. So what I can do is, I can take away 2 from both the sides. So we have 2 plus x equals to 5. I can do minus 2 on both the sides. So equal to means it remains equal to, because we are doing the same thing on both sides. Now 2 minus 2 is 0, so we get x equals to 5 minus 2, which is 3. So that is how you solve. Now normally you may like to check your solution also. So we are just doing it for the first simple set. You can substitute 3 in your equation. So on the left side you have 2 plus 3, which is equal to 5, and that is equals to right side, and therefore the solution is correct. If you have multiplication, 3x equals to 12. Now how could you solve this? 3 times x is 12. We can divide both sides by 3. So if you divide both sides by 3, these 3 cancel out. That is 3 divided by 3 is 1. So you get 1 times x equals to 12 over 3, which is 4. So x is equals to 4. Again, you can check 3 times 4 is indeed 12, right? The next one here is 8 minus 2x equals to 0. Now we do not want 8 here. We want to find the value of 2x. So one of the ways to do it is we could say 8 minus 2x equals to 0. We'll take away 8 from both the sides. We could take away 8 from both the sides. Then we get 8 minus 8 is 0. So we have minus 2x equals to minus 8. And now we'll follow the method which we followed in second case, right? So we can now divide by minus 2. So we have minus 2x equals to minus 8. We'll divide both sides by minus 2, since we want what x is. Minus divided by minus is positive. 2 divided by 2 is positive 1. So we get x is equals to minus minus is positive, x equals to 4. Now you can always check if it works for you. Correct? So these are the cases when we have x on one side of equal to sign. Now let us take cases where x is on both the sides. So again, I have taken 3 simple equations to solve. As we move along, you'll find that this is not in a very difficult exercise, right? And you'll enjoy working with it. So we have 2x equals to 5 plus x. So in this strategy is keep x on left side. So what we will do is we'll keep x on left side, not on the right. So if I have to do that, what should I do? The equation is 2x equals to 5 plus x. I will take away x now from both these sides, right? So I could take away x from both these sides. So we get 2x minus x as equals to x. And we are left with just 5. X minus x is 0. So x equals to 5 becomes a solution. Perfect. Next one is very similar to this. So again, apply the same strategy and solve it. So we have 3x plus 3 equals to x. We take away x from both the sides. So once you do it, you get 2x plus 3 equals to 0. Now we do not want 3, so we will take away 3 this time. So we have 2x plus 3 equals to 0. We'll take away 3 from both the sides. And what we get is 2x equals to minus 3. Now we want x. We should divide by 2, correct? So the next step will be 2x equals to minus 3. We'll divide by 2 on both the sides. So I'm following steps to do these. You can cut on some of these steps. So minus 3 over 2 is what you get. Perfect. The next one here is 2 minus x equals to x. So we have 2 minus x equals to x. I'm leaving this space in between so that I could insert minus 2, right? So we'll take away minus 2 this time. You could do that also, right? And then the x part. Okay, so what we get here is minus x equals to x minus 2, but we want what x is. So let's take away x from both the sides. So we have minus x equals to x minus 2. I do not want x on the right side. I want to keep it on the left side only. So we do minus 2x and we get minus 2x equals to minus 2. Now we will divide by 2, right? So we have minus 2x equals to minus 2. We are going to divide by minus 2 both sides. So we get what? We get x as equals to 1, right? So if you substitute 1 here, you get what? You get 2 minus 1, which is equals to 1. So x is 1, correct? So you see, you can always solve this equation very easily. Now let's take up more examples. Now onwards, I'm going to use a slightly different strategy to solve the equations. We again have 3 equations this time. And now I'm not going to subtract both sides or divide both sides, but we'll kind of do a shortcut. So we want to keep x on the left side. Okay, so let's do keep x on left side. Left side of the equation, I mean. We do not want this number. That means we are subtracting 5 on both the sides. So I could write like this. I could say minus 2x equals to 4 plus x minus 5. Do you see that? So what I did was I moved this 5 to the other side, and once I do that, the sign changes. Correct? Now we are in this particular page, we'll do this kind of operation. Now I'm going to move this x on the left side. Since I want all the x's in the left side, sign is positive, it should become negative. So we have minus 2x minus x equals to 4 minus 5. Do you see that? Now minus 2x minus x is minus 3x, and 4 minus 5 is minus 1. And now we'll divide by minus 3. So x is equals to minus 1 over minus 3. So we can write x as 1 over 3. Is that clear? Now that's a neat way of doing it. We do not really have to show that we did minus 5 both sides, right? And got to that step. Do you understand? This cancels and this happens. So we do not have to do this. It is understood, right? So once you kind of get it, you could adopt this method. This is a valid method. Okay. So let's follow this method and now onwards. So again, we are trying to keep x's on this side, so I could move in the x here. So I'm doing one by one just to make things look clear. 3x plus 3 we have taken this x on the left side, it becomes minus x equals to 9. 3x minus x is 2x. We have 2x plus 3 equals to 9. And now I'm going to move 3 on this side. Since it is positive 3, I'll make it negative 3. So we have 2x equals to 9 minus 3. So we have 2x equals to 9 minus 3 is 6. And now we are going to divide by 2, right? So we have x equals to 6 divided by 2, or x is equals to 3. Is that clear? So you could bring the terms, or when it is coefficient is like this, like a multiplication, then you need to divide. So in this case, we divide it and it comes in denominator. Perfect? Now let's adopt the same strategy, understand it. Now second part, which I don't want to confuse, you could actually take them to the right side also. It's up to you. But we'll keep x on left side. So we're bringing x on left side. So let's bring x's on the left side and take the numbers on the other side. We can do both the operations together. So we could write this as 3x minus 5x, bringing 5x to the left side. And we are left with 4, taking 7 on the other side, plus 7. Do you see that? So you could do both the operations simultaneously. So we have minus 2x equals to 11, and x is equals to minus 11 over 2. So that becomes the solution. Now if you do both the operations simultaneously, which is also the correct way of doing, you save a lot of time. Now let's get into more examples. Now I have examples with fractions. Okay, so we will have fractions now. Let us see how to do such questions. Now whenever fractions are involved, the strategy which I'm going to use is get rid of fractions, right? So the strategy is get rid of fractions. How do you do that? So you have to find the lowest common multiple, right? You have to find the lowest common multiple, multiply with those. That is what you have to figure out. Now, so let's convert these equations without fractions. So here, if I multiply everything by 2, I get rid of this 2 in the denominator. Is it okay? So the first step is we have the equation half x plus 11 equals to x minus 4. What I'm doing here is multiplying everything by 2. Right? So what I'll do here is the whole equation I'll do 2 times, both left side and right side. Is that clear? So when I multiply by 2, I get here x, I get plus 22, I get here 2x, and then I get minus 8. So we got rid of fractions. Do you see that? Now we'll adopt these strategies which we learned. That is, we'll bring x's on one side and the numbers on the other side. So we get x minus 2x equals to minus 8 minus 22. X minus 2x is minus x, and minus 8 minus 22 is more negative, which is minus 30. And therefore x is equals to plus 30. Is that clear? Correct? So that is how you'll do such questions. Now here we have a different kind. In this case, we could cross multiply. So that is to say, we could write this as 3x plus 1 equals to 2 times 3x minus 4. Do you get it? So just cross multiply. Multiply the whole thing by 2. It is same as multiplying both sides by 2. 2 and 2 cancel on the left side and gets multiplied on the right side. So you get the same equation. Open the bracket. So we have 3x plus 1 equals to 6x minus 8. Now bring the variables on the same side. Now here I'm doing a twist. This time I'm taking this term on the right. I'm now keeping x on the right and numbers on the left, since this is a higher number. You could do that also, right? So if you do that, you get removing this And bringing this means you have 8 plus 1 and you have 6x minus 3x. You see that? It's a simpler. We don't land up with negative numbers as we had been landing earlier. So you could take it on the right side also, right? So x on any one side. So that is critical. We are keeping x on any one side. Now that is a strategy for us. That should be the strategy ultimately, right? So we have 8 plus 1 as 9, 6x minus 3x as 3x, and now we can divide by 3, so we get 9 over 3 as x, and we can write this x as equals to 3. Is it okay? So like this, you could solve it. Now let's look into the next question. Now here, what is the lowest common denominator? Well, 2, 3, and 2, that means I have to multiply each term by 6. Is that okay? So what I can do here is, we have half x plus 1 equals to x over 3 minus half. Now we could multiply each term by 6. So 6 times this, 6 times this, 6 times this, and 6 times this. So you could multiply each term by 6. So when you do this, you get 6 divided by 2 is 3, so you get 3x. 6 times 1 is 6. And here you get 6 divided by 3 as 2, so you get 2x. 6 divided by 2 as 3. Correct? Now decide which number is bigger. X term is bigger here. So we'll bring 2x to this side and take away 6. Perfect. We did it because x coefficient is higher here. So we do 3x minus 2x equals to minus 3 minus 6, which is x equals to minus 9. So that becomes our answer. So I hope that is clear, right? So here is the last page. We have 3 more questions to go. You will notice that these 3 questions are different from what we did earlier. What you notice is that x terms are in the denominator. Do you see that? X terms in the denominator. So that makes it slightly different from all the cases. Since x is in the denominator, we know that x should not be equal to 0. That is very clear. X can be anything but 0. Remember that. Since it is in the denominator, you cannot divide by 0. First step. Second, we have to now multiply each term by the lowest common denominator, which in the first case is x, in the second case is 2x, and in the third case is 6x. Correct? So let's multiply each term by x in the first case. What we are doing here is, we have 1 over x plus 2 equals to minus 5 over x. So we'll multiply each term by x. So the step is, multiply each by x. So when you do that, what do you get? You get 1 here plus 2x minus 5. That is what you get. So, I mean, equal to minus 5. So in this equation now, there is only x on one side and the numbers. Let's solve this. So we get 2x equals to minus 5 minus 1. 2x equals to minus 6 divided by 2. X equals to minus 6 by 2, which is minus 3. Right? So we get our answer as x equals to minus 3. You can check this. It will work. Right? So here we'll multiply by 2x. Now times 2x. Both sides. So you could write that as an instruction. So you get, let me do it in steps. So we have 3 over 2 will times 2x, right? Minus 1 over x times 2x equals to 2 over x times 2x. Is it okay? So when you do that, you see the denominator gets cancelled. So you have something which is kind of a linear equation for you. So we have 3x minus 2 equals to 2 times 2, 4. Now you can take this term on the right side. So we get 3x equals to 4 plus 2. 3x equals to 6. X equals to 6 divided by 3. So x equals to 2 as your answer. Perfect. The last one, I'd like you to pause the video, solve this yourself, and then look into my solution. Now here the common denominator is 3 times 2, 6x. So we'll do times 6x each term. So if you do that, in the very first term, when you multiply, you get 3 times x. So you get 3x minus. Here you will get 2, right? Equals to, here you will get 3. We are multiplying by 3, 2 and x, right? So we have x already, but we don't have, I'm sorry, you'll get 6. So when you do 6x, 6 times 2 is 12, I'm sorry. This is 12. Let me redo it. Let's redo it, okay? So we have half times 6x minus 1 over x times 6x equals to 2 over x plus 1 over 3 times 6x, both times 6x, right? Yeah. So what you notice here is that when you divide 6 by 2, you get 3. So you get 3x in the first term. The second term, x and x cancel, we get minus 6. In the third term, equals to, and now 6 divided x and x cancel, 6 times 2 is 12. So we get 12 here, and we get plus 2x. Do you see that? That is what you get. Okay. So we times every term by 6x, the common denominator, and we get this equation. Now it is a normal equation. Bring the x terms to one side, which keeps x positive, and the numbers on the other side. So we get 3x minus 2x equals to 12 plus 6, which is x equals to 18 as your answer. Perfect. So that is how you should be solving equations where the variable is on both the sides. So what we learned here is that you could keep the variable in any one side to solve. Prefer to move it in a way so that its coefficient is positive. That saves one extra step. I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'd be great for me. Thank you and all the best.